This is a demonstration and overview of the 2012 Buick LaCrosse. This LaCrosse has an optional four-cylinder engine with a hybrid system that they call the eAssist for electric assist. This is a direct injected Ecotec four-cylinder engine, and it, combined with the hybrid system, has 182 horsepower and is rated for 36 miles per gallon on the highway and 25 in the city. This electric motor here is an induction motor, and it is liquid cooled. It's got its own coolant pump, a common reservoir with the radiator, but this is both a starter and, a generator and a electric motor to help propel the vehicle at the same time. It uses three-phase AC power from a lithium-ion battery, 130 volts, in the back of the car, and this is the drive mechanism. It actually uses a serpentine belt and a very strong tensioner that you can see off to the left there to keep the tension on that belt. And this electric motor assists the crankshaft in turning under light acceleration and heavy acceleration and cruising, depending on the state of charge of the battery and other conditions, temperature and throttle angle and so on. This system is an evolved system of the GM belt alternator starter system, the BASS system, that came out several years ago. It was used in Saturns and used by Chevrolet in some vehicles that didn't really improve fuel economy very much. This one, they claim a 25% increase in fuel economy. I want to show you the back of the car. I've got the back seats down and slightly out of their place here, and let me turn the light on, get a little more illumination going here. This is the battery pack, the lithium-ion battery pack. As we can see, if we zoom in here, it's 130 volts. This is the disconnect circuit or disconnect switch right here. To disconnect this, these high voltage cables in orange here, so that you can do service on the hybrid system underneath the hood, or replacing cables, or even farther down inside here, there's just a little clip that we pull out, the blue clip right there, and we push in on this button, slide that over, and all that is an interlock, or that's a lock to keep this main switch right here from shutting. And so that has disabled the system. That opens the battery circuit. This battery is in series, has a bunch of cells in series with each other, and this open circuits that series circuit. And of course, with a series circuit, you create an open anywhere in it, and it is a complete open circuit. There's no current in a series circuit with an open. And then to close the circuit again, we push in on this red button, close the switch, slide the lock back over, and push in on the blue lock there. We've got a computer with connections right here that is in control of the battery, and the inverter assembly is back here to switch from AC to DC, and the converter to go from DC to AC is back here. We've got some warning labels about how dangerous it is to work around high voltage. Right here we've got a great big electric motor, blower, acts like a vacuum, and what it's going to do this pull air in on the upper shelf behind the back seat. It then pulls that air over and through this ducting, through the battery itself, and then up this ducting. And then let me get into the trunk next. Here in the trunk, we can see the electric motor and the outlet tube that stops right here. This is behind the trim panel, and then over here, behind or in the body panel area, there are these outlet valves where the air can blow out, but it keeps air from blowing in as you drive down the road. So this, I've got the trim removed in the trunk area to show you the 130 volt lithium ion battery. Let me come in close here to the label, let it focus. There we go. Lithium ion battery. There's that ducting I was telling you about. So this is an air-cooled battery system. And then the cabling comes out and goes down through the floorboard right here and underneath the vehicle all the way to the front of the vehicle, where it comes in up in the engine compartment. There we go, right down in there. It's kind of hard to see. And then that comes up. There's 3 cables in there, as I mentioned, for 3-phase wiring. This electric motor, unlike other hybrid electric vehicles that I've received training on, this motor is an induction motor. It has no brushes, of course. It runs on AC, but it's an induction motor. It is not a synchronous motor like the GM 2 modes, the Toyotas, the Fords, and so on, that have a permanent magnet rotor that rotates inside of the stator assembly. Instead, this has the stator assembly and a rotor set of windings that, as the stator is excited with the 3-phase voltage, AC voltage, it will induce current into the rotor windings and cause the motor to rotate. I don't know why they picked that type of a motor on this vehicle, but it seems to work very well. And as I mentioned, it's liquid cooled. You can see the coolant pipes coming in. Here on the back of the motor, there's a coolant pipe. There's 2 cooling pipes right down there that connect to a portion of the radiator to keep it cool. Now I'm going to put this up in the air and show you underneath the vehicle. So let me do that next. Okay, I've got the Buick LaCrosse up on the hoist, and if we come underneath the vehicle here, we can see right up here, you can see the orange cables back there, and they go up and come down through the floorboard right up there. And then those orange cables, you can see right here, end up going inside of some metal tubing, and then it goes over and up to the front of the car underneath. Now we can't see it because we've got all these we've got these covers to decrease turbulence under the vehicle, which decreases the aerodynamic drag. But the piping, you can sort of see a little bit right here, and it's going to go all the way up. You can see right here, these 2 pipes, those are the high voltage pipes. While we're under here, this uses a new transaxle called the 6T40 transaxle. It's a light-duty light-duty 6-speed automatic transaxle. There's a heavier duty version of this that's used with larger engines that's called the 6T70. And here's our air conditioning compressor. This air conditioning compressor is still belt driven. It is not electric like other hybrid or some other hybrid vehicles. And we can sort of see the bottom of the motor generator, the BAS or the eAssist generator up there. So on this vehicle, if you want air conditioning, the engine will not go into the idle stop mode that it would if you had the air conditioning off. So now let me get a view from underneath the car here, looking back. I'm going to let the car down and we'll take a look at the instrumentation on the dash. I've let the car back down, and I need to mention one safety related item. There are labels all over under the hood and on the battery and the orange cabling warning you that we have high voltage in these systems. As we don't always have high voltage, but unless you're trained and know when that voltage should be there and when it shouldn't, you should assume that it has high voltage. So you should be using Class 0 lineman's gloves when you're working on hybrids. You should also have some insulated tools. Snap-on makes some, and other tool manufacturers make some also for working on high voltage, but they should be rated for 1,000 volts AC. The air conditioning system on this vehicle uses a special, well, on some hybrids it uses a special refrigerant, but this one does not. Notice it says it uses PAG oil, and that's because it's not an electric air conditioning compressor. On vehicles that do have electric air conditioning compressors, it uses a different non-conductive oil. And then over here we have information on emergency responders. If this car were to get in an accident, this shows us where the high voltage battery is in the back of the car, and then where to cut the 12-volt cables. So here underneath the car we've got a label right here saying cut this cable, and a label right there saying cut this cable. That's your positive and negative battery cables for the 12-volt battery that's under this housing here. And if you disconnect the 12-volt battery, that should disable the high voltage battery also, because the high voltage battery has some relays in it. They're called contactors that open up and release or create an open circuit for the positive and negative sides of the high voltage battery. The high voltage battery is DC, of course. Okay, there's one other thing I forgot to show that I want to show for this demonstration on this Buick, and that is the connections back here at the lithium-ion battery. The connections that we have on these two cables, I told you wrong on with this black cable underneath the car. This black cable, as you can see, actually has the DC output from our inverter converter assembly here that goes up to the 12-volt battery under the hood, and the ground is provided through the mounting bracketry at the bottom of the battery here. So there would be a constant 14.5 volts on this red wire here when the system is enabled, and it's all disabled now. That will charge, that keeps the 12-volt system charged. And then, as you can see down below here, we've got the three-phase cabling that goes up to our induction motor up underneath the hood. So the orange wires are the AC voltage 3-phase cables. The black wire is the 14 volt or so output DC, because there's a DC to DC converter inside of this inverter converter assembly that steps down the 130 volts DC to 14 volts when the engine is running and the generator is turning. This cover right here that covers up the cabling connections at the inverter converter assembly and the battery assembly, on the switch here to disconnect and shut off with this switch right there, the high voltage DC from the circuit. This switch has up inside of it, if you look carefully, you can see 2 electrical terminals there. That's part of the interlock circuit. And if there's an open anywhere in the interlock circuit, the relays that are inside of this battery module won't close, and those relays provide the positive and negative connections to the inverter assembly, and that is what is needed to invert it to AC to run the vehicle, or run the induction motor. So this connector right here plugs in to this gray connector right there as part of the interlock circuit. And there's interlock circuits throughout all the hybrid components on this vehicle to prevent anybody from getting injured. If you undo anything on this system, it disables the system by watching the interlock circuit. Okay, we're inside the vehicle and we're looking at the instrumentation. Let me turn the power on. In the center of the dash here, we've got the charge level of the high voltage battery. And if I start the engine, depending on the state of charge of the battery, it may show the engine with some powertrain arrows as far as the direction of current. It's not showing it to us right now. I think the battery is charged. Over here in the speedometer area, we have an eco indicator, which tells us how we are driving as far as fuel economy. We want to stay in the center of that as we drive for the maximum fuel economy. And then for air conditioning and the other instrumentation, if we look over here, right here in the center of the dash, there's a, let's see if it'll auto zoom or focus here. There we go. An eco air conditioning, and then full air conditioning. They call it comfort air conditioning. And what that means is that in the comfort air conditioning mode, the engine will not go into the idle stop mode, and so you'll get the best cooling, but you won't get the better fuel economy from the engine being off. In the eco mode, it'll try to go to idle stop, I believe, if I remember my training right, but it may cycle the engine if necessary to run the compressor, depending on cabin temperature. So we can just turn off the AC also. So we can be off, we can be in the eco mode, or we can be in the full air conditioning mode. If I shut it off and the engine is warmed up and the battery state of charge is good, then notice here in the tachometer area, there's an auto stop mode. And to go into auto stop, a lot of conditions have to be met that I just mentioned. Coolant temperature, catalytic converter warm up, battery state of charge, and so on. If this engine were warmed up and I've got my foot on the brake in drive, it should go into the auto stop area right in here. If you turn off the engine, the tachometer needle will go all the way down to off. So that's how you tell the difference between the auto stop and engine off. Because in the auto stop mode, the engine is off, but the power to the vehicle is still on, and the engine can start up at any time to charge the battery as needed. There we can see on the eco indicator, now that I've let my foot off the brake, you can see the direction of current. When I slow down, it goes back into the battery. When I take off, it leaves the battery in the generator. So battery charging, engine power. So as you drive down the road, this eAssist system, and now it's got a service StabiliTrak message because I'm running the vehicle on the hoist. But as you drive down the road, this eAssist system helps the engine's crankshaft rotate, which improves fuel economy. So this has been a demonstration of a 2012 Buick LaCrosse eAssist system.